So that's what we do for conversation following the lecture, just as we would if we were meeting face to face. Now, I'd like to introduce our speaker. Jim Miller has an impressive academic background at Yale, Stanford, and the University of Chicago in the fields of economics and of law. He's a professor at Smith College, but we know him in this transhumanist or rationalist community for his book, Singularity Rising, and other contributions to the areas we love in futurism and existential risk. So now is our chance to hear from Dr. Miller on X-risk and the Fermi paradox, please.
Well, thank you very much. I'm quite grateful that you invited me here to talk. So let's start with an analogy. Imagine that there's a mountain that you absolutely have to climb up. And there are several paths you could take. And it looks like one of them is probably the safest and probably the easiest. So it's the path you intend on taking. Now you're uncertain how many people have tried to climb up this mountain. Maybe you're the first. Maybe one or two other people have tried to climb. But maybe hundreds, thousands, or even millions of people have tried to climb this mountain. You have a lot of uncertainty. But then you learn something somehow, and say an oracle tells you that if anyone else had ever tried to climb this mountain, they failed and they probably died in the attempt. So you learn that no one has successfully climbed this mountain before. It could be because no one's tried, but it also could be because many, many people have tried and they all died in the attempt. How should this knowledge that no one has successfully climbed this mountain, how should it influence the path you take to climb the mountain and what you do when climbing? I think this is a good analogy for the Fermi paradox. That I'll briefly cover the Fermi paradox. I imagine you're all familiar with it, but basically, the Fermi paradox is the fact that we don't see signs of life in the universe outside of Earth. And, brief reasons why this should confuse us. There seems to be a vast number of planets in the universe, huge number in our galaxy. We don't appear to be special. It's not like our sun has some weird characteristic that other suns don't. And, and you're probably limited to traveling at the speed of light, no matter how advanced you are. Basically, our galaxy is older than it is big. So, even if you traveled at 1% of the speed of light, you should be able to cover the whole galaxy. Think there'd be time for some civilization to have gotten everywhere. We also observe probably intelligence. It's not that evolution couldn't really figure out intelligence and it just got it once, because if you look at the common ancestor of, humans, crows, and octopuses, it was pretty dumb. So at least at the level of octopus intelligence, that can't be that hard because it's arisen twice. And, maybe would an intelligent race want to expand, want to spread out? I mean, you'd think so, because evolution should be favoring creatures that want to spread, right? I mean, if life has evolved on other planets, it evolved from the same rules of evolution. And the key thing of evolution is you want to spread out. So why isn't there some other civilization that spread out? Also for reasons of safety. I mean, the more you spread out, the more resources you get. I mean, just think of human history. It could easily have turned out that, the Nazis or the Mongols under Genghis Khan type leadership took over, and their goal was to conquer as much of the universe as they could. Right? And if that's what we were like, if you were another race, you would want to grab as much resources as you can just to protect yourself. And there's also an anthropic argument that I think is very powerful. So imagine that things go well for us and that we're basically alone in the universe. If things go well, pretty soon we'll be beyond any local disaster, right? We'll start to spread out. And then once we've started expanding, there'll be nothing that can get our civilization. We'll keep going probably until the end of the universe, which could be trillions or 10 to the trillions of years away. And that makes us weirdly special, because if you think about right now, we have the capacity of destroying ourselves in a way we won't come back up. That wasn't true, say, before 1970. And if our high-tech civilization continues, it's likely to soon not be true, certainly within 1,000 years, because we'll have spread too far. And again, if the speed of light is the limit, there'll be no way of getting all of us if we are alone in the universe. That means that if the universe kind of is like it looks like, that we're alone, within 1,000 years, we'll be able to expand and start colonizing other worlds. We're all really, really important. I mean, like 1 in a trillion squared important. And it seems unlikely that if you decide that you're that important, that there's not somehow a mistake in your theory. One possible mistake in the theory is that we're not that unique. There's lots of civilizations at our level of development. There's lots of people like us. And the cause of the Fermi paradox is that something knocks down civilizations, that lots of civilizations reach our level of development and something knocks them down. And Robin Hanson has coined this the great filter. The great filter is what prevents a star system from giving birth to a species that would make itself known to a species at our level of development. And if the great filter is in front of us, it's going to probably hit us relatively soon, because again, certainly if things go well in the next 1,000 years, we will be beyond any disaster. So this is a serious problem. This is a huge civilization level problem of how do we survive? Now, I should say there has been one recent paper looking at the Drake equation, and it's saying, well, maybe we shouldn't be so surprised to be alone if you look at all the different things that would go on. And that might be true. That changes the weight of what I'm going to say, but it doesn't change the direction. So it's going back to my mountain analogy. You've learned that no one has successfully climbed a mountain. Maybe many have tried and failed. That should cause you to not take the obvious path, to think probably, there's some chance that a bunch of other people have tried. Probably the first few people took the obvious path and it didn't work out, or at least there's some chance of that not working out. And that should put you to taking less obvious paths. You should also increase the chance that there's a hidden trap on the mountain. Maybe there's a cave with a bear and the bear eats everyone who tries to climb up. And, before you realize no one had successfully climbed the mountain, you might have put the chance of it being a bear cave hidden on the path, that's just too small to worry about. But now you maybe should. And this applies even if you think there's only a 10% chance that someone else had tried to climb the mountain. That makes it slightly more likely that there's that bear cave, or that the path that you think is easy really isn't. So even if there's only a small chance that there have been other civilizations in our galaxy that reached our level and then failed, that's Bayesian information. That should still push us to be more cautious or to try to do other things that we would otherwise have done. So the way I want to look at this is from a Bayesian viewpoint. Imagine there was a cloud covering our solar system that we couldn't see out of it. And everyone thought, well, our solar system was all there is. We were in an island universe of just our solar system. And, we formulated various beliefs. Then we discovered a way of looking through the cloud, and we could see what we do now. How should that change our strategies for handling existential risk? How should realizing that, oh my gosh, there's vast numbers of solar systems and planets like Earth, but yet we don't see any life, how should that change our strategies going forward? And that's what I want to talk about here right now. So I think we should be looking for traps. We should think that there's, what could be a cause of the Fermi paradox? Well, when we were developing atomic weapons, or in the Manhattan Project, there was a bit of a concern that, when you ignite an atomic bomb, it would ignite the atmosphere and destroy all life on Earth. And they did calculations and they said, no, this isn't going to happen. But imagine it was going to happen, but for a reason that you don't figure out until you've solved string theory. So igniting an atomic bomb will destroy your planet. But you're going to be able to ignite an atomic bomb long before you'll be able to realize that doing so will destroy you. That could be a Fermi paradox. That could, knock down a lot of civilizations. Or it could be something else. There could be something that a high-tech civilization is probably going to do, and it will destroy your planet or destroy your solar system. Wouldn't destroy your galaxy. We'd probably see evidence of that. And that's a trap that's kind of hidden in the laws of physics. And we should be more wary of that than we otherwise would be. Now, if you think there's only a 10% chance that in our galaxy, say, another civilization like ours has arisen, and the fact that we don't see it as only small information, that just slightly increases the chance of it being a trap. But it still pushes you in the direction that you should be more careful. Now, we have an advantage over civilizations that existed in the past. And the main practical result of my research on this area is that I'm saying we should take advantage of this advantage. And that advantage is that we face a more paradoxical Fermi paradox than anyone who's existed in the past. So let's imagine that, if we knew the true state of what was going on, we would be really pessimistic. Let's imagine that in our galaxy, 1,000 civilizations have reached our level of development, and all of them, went extinct, crashed. That, we would all update to be kind of scared. But we know we have an advantage over these past civilizations in that we exist at a later time in the universe, and so we should be more surprised by the Fermi paradox, which should cause us to be more careful, right? So these past civilizations, if you arose relatively early, you would have looked out, the galaxy, the universe, and say, well, gee, we don't see any intelligent life. But that's not that surprising because there hasn't been time. So they wouldn't have looked for these traps. The longer you go, the longer it takes for your civilization to arise, the more time there's been for life to have developed and to colonize galaxies, the more surprised you should be at a civilization at our level of development to not observe this. So we have more information than any other civilization at our level of development that, existed in the past. And let's try and take advantage of this. We should be putting more resources into looking for traps. We should be more careful. So if there's a particle physics experiment that's going to create conditions that have never existed in the universe before, we should assign a higher probability than did past civilizations that this could go disastrously wrong and it will destroy our civilization. We also have greater incentive to search for the remains of dead civilizations. It's possible that, when there's a trap in laws of physics or something, and then when this trap is sprung, that it leaves remains. Maybe there's a solar systems that are destroyed, or we'll somehow see remnants. So we should be putting more research compared to if we didn't have a Fermi paradox, because say we're very early, into, in scanning the sky looking for the remains of dead civilizations. The Fermi paradox tells us something about the nature of traps. So we should be more concerned about traps that would hit every civilization, every kind, than one that might just hit us. So, if a lot of civilizations have arisen, some might, have come from, say, the equivalent of insects or aquatic life. So we should think about what kind of trap might get them, might get all kinds of life that would arise as opposed to just us. So one weird way out of the Fermi paradox is maybe we should uplift other species, like raise the intelligence, not monkeys, they're too close to us, but maybe raise the intelligence of dolphins or octopuses, and, and talk to them and see, gee, what would you do that's the same as us? And then the things that we would do in common are the things that are the greatest risk. we should also be willing to try more long shot strategies. We should think to ourselves, the obvious ways of going out and colonizing the universe, the ways of keeping safe, there's at least some chance that these aren't going to work. So we should be thinking, of things that the civilizations wouldn't have tried if they, if they were very early in terms of the Fermi paradox. Let me talk now about the Fermi paradox in AGI risk, artificial general intelligence. So I imagine you're all familiar with the problem of the paperclip maximizer, right? So this is a thought experiment by, I think, Eliezer Yudkowsky. And the danger is we'll create an artificial general intelligence that'll be smarter than us. And because it's smarter than us, it could outthink us, it could take over. And it might have some goal that we don't share, and it will just use all the resources it can to further this goal. So Eliezer Yudkowsky said, he doesn't think it really will be paperclip maximization, but paperclip maximization is just a proxy for a goal that is just really boring but would destroy us. So the idea is we create, a computer superintelligence, say GPT-7, and it decides I like paperclips, and it just converts all of the atoms it can, including the atoms in our body and our solar system, into paperclips. And it will basically expand out, grabbing all the atoms it can in the universe, converting them to paperclips or whatever else it cares about. A paperclip maximizer can't be the solution to the Fermi paradox, because we would see it. If civilizations fail because they create paperclip maximizers, that would be really visible. We would see these expanding spheres of paperclips, or just expanding spheres of something grabbing all the resources it can. Now, maybe the AGIs get really good at expanding, and they expand at the speed of light, so we wouldn't see it till it hit us. But if this was the case, then we would be surprised to exist this late in the universe. So if it was common for civilizations to destroy themselves by creating paperclip maximizers, we should either see evidence of this if they expand relatively slowly, or be surprised to exist. So it's very likely that paperclip maximizing, basically AGI going very wrong, it's very unlikely that that is the cause of the Fermi paradox. But that actually gives us some potentially useful information into dealing with AGI risks. It means that either, paperclip maximizers aren't a big risk to civilization. Let's assume that the cause of the Fermi paradox is a great filter that exists after us. So we somehow find out lots of civilizations have reached our level of development. Given that assumption, we would have to conclude either it's really hard to create paperclip maximizers, or it's such an obvious danger that almost no civilization tries it, and that's why we don't see them. So that's kind of good news. The bad news, though, if civilizations are common and fail, the bad news is that creating AGI can't be an easy way out. It can't be that, GPT-5 or so is just going to allow us to colonize the universe. Will tell us the secrets, assuming lots of civilizations have reached our level of development and failed, because if that was true, we wouldn't see a Fermi paradox. There's a weird anthropic argument I want to make about the possibility of a hidden trap. So let's imagine that there's a multiverse, and the multiverse has different laws of physics in different universes. And, in most, of course, the multiverse, life is possible. In a lot of the universes where life is possible, let's imagine, Eliezer Yudkowsky is absolutely right. Civilizations develop, someone idiotically creates a paperclip maximizer. That's the norm. Well, you're not going to have a lot of civilizations like us in that universe, right? If there's a universe where lots of civilizations like ours can develop, but paperclip maximizers are common, that's the normal course of events, is for a civilization that once it industrializes, it quickly creates a paperclip maximizer. You're not going to have a lot of civilizations like ours, because the paperclip maximizers will quickly consume the resources of the nearby universe. So the universes that have the most civilizations like ours might be one where there's a great filter shortly after you industrialize. That, there's a great filter that hits you before you can create a paperclip maximizer, and that makes us common, and that prevents us from spreading. So even if there's something hidden in the laws of physics in a tiny number of universes, those universes that cause a late grade filter, those are the universes where most people like us might actually exist, because in the other universes, something, probably a paperclip maximizer, quickly grabs all the resources. And so we're common. You can make an anthropic argument that observers like us might be most common in universes where it's easy for life to develop, but it's very hard to actually start colonizing other planets because something gets you. And so that's sort of an anthropic reason to be very worried. So this line of thinking, it's sort of given me an effective altruism proposal. And it's kind of weird, but I think this community might be open to it. So let's imagine that we are really doomed. That if you knew everything, you would look at us and you'd be like, yeah, tens of thousands of civilizations have arisen in the galaxy. They've all gone under. And you guys, given what you know, you're not going to avoid the trap. So just, that's the state. We're doomed. Something's going to get us. And because we don't know what it is, we have no hope for survival. Maybe. But maybe we can help future civilizations. So here's a proposal that I have. I would like us to create long-lived satellites, have them, orbit around Earth, maybe even better, far away from the Earth, solar powered, that will survive as long as they possibly can. And we would continually update the satellites. We would update it with, the latest status of our civilization, but most importantly, the latest news events. And the satellites were designed, they'd keep quiet. They'd do absolutely nothing but receive this information until they didn't hear from us for, say, a year. So if the satellites didn't hear from anyone for a year, they would start blasting out to the stars. And they would say, they would say everything about us. We've probably been destroyed. And here's the latest things that have happened. So, maybe it would say, gee, civilization's destroyed. The latest news events are scientists very excited about new particle physics experiment. So the idea would be that if we are doomed, maybe we can save the next civilization. We could save people. We could save other sentient life by recording what's going on with us and transmitting that information out. Also, if we do ever encounter other life, we don't destroy ourselves, the fact that we did this would be a really good trust signal, right? It would show we're willing to devote resources to help people who aren't us. So maybe us doing that, that in sort of a game theory way would be a way for us to earn trust of future civilizations. And if you think game theory might be kind of universal, maybe other civilizations have done that. So other civilizations have come up with a mechanism whereby they will transmit, if they're destroyed, what happened to them, and we should be looking for these signals. Don't know. One other weird thing, causation can get kind of strange, and there might be a way for us to pass the great filter, like in the next month. I don't know if it'll increase the chance of our survival, but so if you think technically what the great filter is, it's that no civilization has able to make itself known to a civilization at our level of development, right? It's not just that we can't talk to aliens or meet them. It's that we don't see any trace of any, say, intelligent life outside of Earth. What would happen if we started to make a huge amount of noise on Earth? We basically spammed our galaxy with radio signals, and we did things like the satellite said. Instead of waiting for us to be destroyed, we sent up satellites that would continually transmit anything. They could transmit prime numbers. They would do anything to make it maximum likely that if there are other civilizations in our galaxy, they would they would see us. If there are other civilizations at our level of development, they would see us. Once we did that, we would kind of be past the great filter, right? Once we made enough noise, in some ways we would have precluded the worst possible outcome, or the worst outcome is that there are currently tens of thousands of civilizations in our galaxy, and something gets all of them before they can make any noise, before they can do something that leaves a trace to a civilization like us. Well, if that's true, we could make a huge amount of noise right now, and then we know that that worst case thing isn't true because we will have passed the great filter. We will have left a trace. Now, does that actually make us safer? This gets into kind of weird causation theories that I don't fully understand, but so maybe not, but at least it might give us a little bit of peace of mind that the worst possible outcome for the great filter can't be true, because we have made enough noise that a civilization in the galaxy at our level of development would have seen this. Now, of course, the downside of making a huge amount of noise is if, like the dark forest theory of the great filter is true, and that the reason you don't see anything is everyone's hiding from their neighbors. That doesn't seem likely to me, because it seems, if you were an advanced civilization, it would be pretty easy to find other life. I mean, if you pointed a telescope at Earth and you were, even 100 years advanced from us and you were a galaxy, you would definitely see that there's something going on here. You send a cheap probe. So it seems unlikely that you can hide. So I don't see how much we would lose by making a huge amount of noise, but that is a potential cost. So that's my proposal. Again, to summarize, from a Bayesian perspective, the great filter provides us with information. The great filter, the Fermi paradox, provides us with information that we didn't already have. We know there is at least some chance that other civilizations have reached our level of development and failed. And that can influence our future choices, that can influence our resource allocation. And we should do this. I think that the best ways are to be more cautious about traps, and also to search as best we can our galaxy for remains of dead civilizations to gain even more information. Thank you. I'm happy to take questions.
Hi, this is Joshua. So everyone, feel free to write your questions in the chat. I see we already have one, plus I added one. So just keep writing those and I will go ahead and read them off. Stig asks, we have used 13.8 billion years to reach our level. How fast could we have reached this level under optimal conditions and luck?
My understanding is that we certainly could have done it, a billion years ago. That, our sun formed, I think, over 1 billion years past other similar suns. So that's plenty of time. It's obviously a civilization that reached our level 1 billion years ago could easily have colonized our galaxy. I don't know the exact time, but I do know there's been plenty of time for other civilizations to have developed that are, similar to us.
Okay. Spencer Bringleson asks, if other civilizations are capable of creating paperclip maximizers, are they not capable of this same line of thinking? For example, creating a lot of noise, signaling their existence?
Yeah, that is definitely true. So that's to say, if there are a lot, why haven't they made a lot of noise? And it could be that my line of thinking is completely wrong. Maybe that's creating a lot of noise is a very weird strategy. I don't know how many people would think towards that. But yeah, you would think if there were a lot of civilizations, some of them would be making a huge amount of noise. We don't observe that, so that's evidence that there's not a lot of civilizations. Yeah, so that is a good point. That is, you should use Bayesian reasoning on that. I hadn't thought of that, but that does make sense.
Okay. Michael Zhang asks, how many stars in the galaxy can we currently detect a civilization like us around? I thought it was only a handful.
Well, it depends. I mean, Certainly, if they're sending out a lot of radio signals, we could detect. I think, yeah, this is a bit beyond a lot beyond my expertise. I think if you can look at planets and you could see, from the atmosphere if there's life on it. But I mean, a bigger deal is, don't think of us now. Think of us 1,000 years from now. Most likely, if things go well, we don't collapse. It'll be really, really obvious if you look at our star system that there's intelligent life here.
Okay, Ben-Sion Kosowski asks, is this whole theory not predicated on our viewing ability? For example, any case in which we don't manage to observe the external phenomena we predict to exist, or if the phenomena existing in a form which we can't view, renders our logical chain much less convincing, no?
Yeah, I mean, it's definitely predicated on sampling, right? We're observing stuff and then we're updating our beliefs based on that. So for example, if the Fermi paradox is that intelligent life basically leaves the universe or turns into dark energy, we wouldn't be able to observe it, then yeah, this theory has less weight.
Mm-hmm. Okay, Julian Felix Fleury asks, in my opinion, it's likely that we end aging in this century. This is probably a likely thing to happen for any civilization. Could it be that they just exist over a different time scale compared to us? And that might make it very hard to detect them.
That's certainly a possibility, but you would think if for reasons of self-defense, you would want to be grabbing resources and you'd want to be capturing energy of stars. I mean, stars are giving off a lot of free energy that if our understanding of thermodynamics is right, you'll never get back. So, I mean, you speak about ending aging, and I certainly hope we do, but you can't really, give yourself immortality because you need free energy to exist. So if, we end aging, well, look, gee, well, we can survive a long time, trillions of years, but there's a limit. But if we, capture the energy of stars, that limit goes up. So stars are wasting a huge amount of energy. You'd think life forms that can live as long as their free energy would want to do that. They would, resources are being wasted. Why would an advanced civilization be letting that happen if it didn't have to?
Okay, I'll ask one on my behalf. Beyond the concept of shouting, Earth could be detected from the moment we invented radio technology. So does the concept of shouting, which I think is brilliant, really add anything?
I think so. I mean, imagine there is another civilization, halfway around the galaxy from us at our level. It's not going to probably with, the radio, it wouldn't be listening into the radio frequency at the right time. I'm guessing we could make it far more likely that we'll be heard. We could significantly raise the odds. And of course, the easiest way to raise the odds is, of course, across time too. If we put out satellites that continually shouted and they would go, even if our civilization destroyed itself, we would vastly be increasing the time frame that we would have left a trace.
Okay, Scott Owens asks, shouldn't we have detected the remnants of civilizations? Wouldn't other civilizations have sent the long-lasting warning the long-lasting warning you have proposed, which I think is a little bit different from the shouting. It's the long-term satellites concept.
Yeah, assuming that they think the way I'm thinking, but we can't know that they would, right? So it makes sense to me that we would do this, although to the best of my knowledge, I think I'm the only one I'm originally proposed this, so that doesn't mean that even a lot of humans would have thought of this, so it might be rare. This is actually an advantage of uplifting another species, is that we see what would be obvious to it and weird to it. And if, something, oh yeah, this makes sense to dolphins and, intelligent dolphins and octopuses, then we should say, oh, other civilizations that reached our level had tried it, but, maybe it didn't. I mean, maybe the idea of being altruistic to other people is something that it's just a weird quirk of our evolution. So maybe, we're very strange in that.
Mm-hmm. Okay. Michael Caton asks, isn't it way too early to say that we're alone? We're still finding metazoans in Manhattan.
I don't think so, because what you would guess would be it wouldn't be hard to find other life. Just like you go into your backyard, you find evidence of life. Why hasn't evolution resulted in there being advanced civilizations that want to go everywhere, to spread their religion, to spread their philosophy, to grab resources. So I mean, it's certainly, there could be, I mean, it's way too early to say definitely we're alone, but what's surprising isn't that we can't find civilizations after looking. It's surprising that it's not overwhelmingly obvious. As obvious it is that we can find life in our own backyard, because life should want to expand.
Okay. Patrick asks, if we know making a bunch of noise is possible now, why do we need to actually do this? Is not the knowledge that we can do this sufficient to rule out those worlds where we are unlikely to get to the stage where making the noise is possible?
Oh, that's a really interesting point. Of course, you could argue that that's what happens, right? That lots of civilizations reach our level of development. They're like, well, we could make noise, but the fact that we could means we don't have to, so none of them actually do. So you have to, like, I imagine there's some equilibrium modeling there.
Mm-hmm.
But that is an interesting point.
Gary Nauman asks, how local might the Great Filter be?
Well, I think it's more like a great filter is more likely to be something that gets every civilization at our level rather than some peculiar quirk of our solar system or our evolutionary history. Unless, of course, the great filter is there's lots of local problems. So, but I think it's more, we should be most concerned about traps that knock down anyone that's industrialized, including, what would happen if octopuses became smarter and were able to colonize other worlds.
Mm-hmm. Okay. So James Faville asks, he says, outside of game theoretic considerations, I'm not sure whether helping other civilizations by shouting, for example, past the Great Filter is good in expectation. It depends on how value-aligned civilizations that could pass the Great Filter with our help would be with us in ways we think are important, e.g. would they be altruistic? What's your take on this?
Yeah, I mean, that's certainly true. You're right. There could be like baby torturing civilizations out there, and it's better if they didn't exist. So yeah, to do this more rigorously, you'd have to model, would a random civilization that hurt us by our values would be making the universe better or worse if we helped it survive?
Okay, Michael Patton again asks, the rationality community is very focused on the dangers of an AI singularity. Well, this is not inappropriate. There's a mismatch between that interest and motivation to stop reckless attempts to advertise our presence. How to change minds about attending to this existential threat and how to enforce a global moratorium?
Yeah, I mean, I think it's very unlikely we'll have a global moratorium on AGI risks. I mean, if you compare it to risks of climate change, right? I mean, whatever you think of climate change, our elites seem to genuinely think it's a huge problem. And, economists, we know what to do. I mean, you have, carbon tax plus atomic power. We can take care of this. We can't coordinate to do it. AGI risk is a lot harder to deal with. I think that we're in serious trouble because I mean, even some top technologists don't believe that AGI risk is real. So if it is, someone's going to keep pushing keep pushing, trying to make things better and better. So I think our only hope is for people to figure out how to make friendly AGI before someone inevitably creates really smart AGI. But I think coordinating to stop this is beyond our competence as a civilization.
Okay, Leonid Chujoy asks, is it implausible that other civilizations have just lost interest in expansion or contact? Perhaps they've chosen virtual reality instead.
It's not implausible if there's a few. It is if there's a lot. Again, evolution should really want to push you to expand, right? Evolutionary psychology should apply. You also, that virtual reality, it's going to have to run on free energy. You get more free energy the more you expand, and you're going to be afraid of your neighbors. Again, evolution is really, really nasty, right? Red in tooth and claw. Even if you're completely friendly and you just want to play your video games, which for me, I can live trillions of years playing video games in virtual reality. That's utopia for me. I'd still be terrified that eventually some alien race is going to come and kill me, take my stuff, make me convert to their religion, make me worship them. That's there's a lot of that in nature. So I think you're going to want to protect yourself, and probably the ways you'd protect yourself would be visible to your neighbors, because you'd be turning off stars, moving things around.
Now, Scott Owen says that the human race was fairly stable before the development of civilization. Wouldn't it be expected that most species that develop sentience wouldn't develop civilization?
Yeah, I mean, probably. I mean, it depends on what's sentient or not. I mean, I stared at my cats for a while thinking if they're sentient, and if, cats are sentient, then most civilizations don't. But, it could well be that that we're only around because we're only the first civilization, the first species smart enough to create civilization. That'll be the last, because it'll go and gobble up all the resources. But yeah, I don't know. And again, I don't think there's anything that was really weird in our development, right? It wasn't like our brains are so different from chimp brains, or, I mean, my understanding of, the human brain is really limited, but I don't think there's anything really, really weird that happened. And you would think intelligence should be kind of useful, at least to some species. So, yeah. But yeah, I'm not sure. Again, there's something, I mean, if there's something weird going on, if, the Fermi paradox is saying something weird going on, and we should be confused. So I'm probably making a mistake in at least one of these answers, because what's really happening?
On a similar note to the above, James Favell asks, on a similar note to the above, how could a late great filter be selecting for different sets of values?
I'm not sure for different value. I mean, for different types of people. Like, again, it could be that there's some scientific experiment that everyone wants to perform that seems extremely safe. You'd have no reason to think it was dangerous unless you take into account the Fermi paradox. So that the technological path to colonizing other worlds, it could cross the same point for different races, because even if, even it's insects that develop civilization or something, the universe is the same, the laws of physics are the same, so they all might do the same thing.
Okay, a question for me. Given, what do you think is the answer to the Fermi paradox, given that astronomers are finding so many exosolar planets, and given that radio signals can be detected at such a distance, what do you think is happening?
Well, this doesn't really relate to what I said before, but I think there's a decent chance that the simulation hypothesis is true. So imagine, there was one civilization that arose, and maybe it arose early, and that civilization, people in that are playing video games, they're maybe simulating what happened, and we're, so maybe the reason we don't have a Fermi paradox is because we're in a simulation, and it's just the simulators haven't put it in yet. They're going to let us develop, and then maybe we'll meet aliens later on.
Okay, another question from someone else. When exploring the laws of physics, should we just be quantum suicidal and counter anthropics to save us from any X-risk traps?
Quantum suicidal, that could get really bad, because you could die in very painful ways, right? That might, I don't know, you'd have to work that out carefully to make sure that you didn't, on the path that you survived, you were in intense pain.
Okay, thank you. Thank you, Jim. That was great. Now, I've read off some questions, and now would somebody like to just speak up and answer and ask questions? Following that, we'll go to the video chat room. So anyone, if you'd like to unmute and ask a question, please go ahead. So I'll give you another chance if somebody wants to ask a question. But of course, we can continue discussing the exact same subject matter in the chat room. So again, does anybody want to speak up and ask?
This is Mike Hayton. Can you hear me?
Yes, I can.
Great. So I had asked the previous question about global moratorium, and I apologize. My question was unclearly worded. I had meant a global moratorium on advertising our presence, a la the METI project. Although your answer with the singularity was pretty pessimistic, so I don't know if it'll be different for this.
Yeah, I mean, I don't know if we could do that. I mean, people have different views over whether it's good or not and how much risk there is. Let's assume that we all agreed that it was a good idea to try to hide. We probably can't, especially since there's going to be other things we have to. I mean, we should all be like a million times more worried about bioterrorism and doing experiments with viruses. So even if we're worried about this, it's probably not going to be at the top of anyone's list. So to the extent we're going to organize, this won't be near the top. But again, I think we're not really good at coordinating to work on XRIS for things where it's not even clear what direction we want to go.
Yeah, thank you. That makes sense. And then one other question, going back to what you were saying about paperclip maximizers and your argument that we would see some evidence of them if they existed. What do you think about the idea that although an AI would certainly be powerful, it still wouldn't be omniscient and might end up having the same problems with the impact of its actions overextending its ability to predict that impact? And that would affect your argument by saying that many of these, maybe most of such paperclip maximizer explosions would actually just kind of flare out, that they would sort of consume all the resources in a way that they hadn't predicted and collapse, and that would be the end of it, and we wouldn't actually see them.
I mean, maybe. I don't know. It doesn't, I mean, it would seem not that hard to, send self-replicating factories and just, send them out to different planets and to different galaxies. I mean, there might be something, again, that there might be some trap that stops that from happening. I don't see what it is right now, but it could be there, and that could be part of the explanation for the Great Filter.
Okay, thank you.
Sure.
Hi, can you hear me?
Yes.
So, all of this seems to be based on the assumption that detecting life is really easy, and you kept mentioning that any species would want to consume free energy and so on. It seems to me like that could easily be something that might change with a better understanding of physics, and that then it becomes very easy to cloak civilizations.
Mm-hmm. Yeah, I mean, so there's, thermodynamics as we understand it is wrong. You don't need to expand to get resources. Maybe you don't need to expand to protect yourself. But still, why not expand for philosophical reasons? I mean, imagine we reach that stage. There certainly would be humans that would want to contact alien races to convince them to convert to our religion, to make them better off, to enslave them, or just because it's interesting. So obviously, maybe that kind of implies that either we're really, really strange in our philosophy, or that something, once we can start expanding, something is going to necessarily change us. And that's possible. You also have, Malthusian trap. I mean, once you can't escape, population growth. Again, evolution should favor people that want to have lots of children. And at some point, there's not space for them, right? Even if you have all the free energy you want, if you haven't you can't easily travel to other universes or something, where do the new people go? You would think evolution would favor someone who says, all right, everyone else is on Earth, but I want to go out and have my own colony there. And then my children will want to go out and have their colony or something. So it's not just the energy question, it's the space question. And you'd think someone would want to have a lot of kids. Someone would want to colonize the universe.
Hey, this is Benzi. Can you hear me?
I can, yes.
Perfect. So we started off this discussion by talking about the fact that as if we're going up the mountain and we're trying to find the path that probably others haven't taken because the normal path may be fraught with danger.
Yep.
If we end up convincing everyone in the world that the most altruistic thing to do is to send out signals, isn't it probable that other civilizations similarly altruistic also were convinced by that, and the great filter would actually be wasting your resources trying to send out signals rather than using them for other ends, right? You kind of run into this like game theory. If you make a rational choice, then all other actors should have made that rational choice.
That's certainly true. I mean, I wouldn't advocate, spending more than 1% of our resources sending out the signals. And it also could be our altruism is somewhat unique. And there also could be middle cases, right? So that what your argument works well if we know it's either 0 or over 10,000 civilizations like ours in our galaxy. But what if there's like 7 right now? Then it could be a few of them are sending out signals, but we haven't seen them yet. But us sending out signals will make it more likely that some of the others will survive. So the proper way of looking at all this is to take what's your range, what's your probability range, and then how does observing things affect that probability range?
Agreed. It definitely seems to need to be quantified a bit more.
Yeah.
Cool. So I'm James. Thanks for the talk. I just wanted to expand on the point I was trying to make in the comments about the great filter selecting for values. So I could imagine that certain qualities help civilizations pass a late great filter, like this bent towards expansionism or maybe a risk aversion. And so I'm wondering, I'm not sure what those qualities might be. And I guess there's kind of 2 interesting takeaways we could take from beliefs about those qualities. Given that we don't see any civilizations, it might be that those qualities are less frequent than we would otherwise think. And also maybe if human civilization dies out, we'd have an expectation that future civilizations that might arise in the universe and pass the great filter would have those qualities. And then that might inform our beliefs about how bad extinction is and that sort of thing.
Yeah, that certainly makes sense. Again, it could be that it takes the right type of values to pass. So we would expect, if a lot of civilizations have arisen, that the common type of values that evolution has given you aren't the ones that are likely to make it. And this is another argument for uplifting a few species, just to gather some more information. But yeah, and also could just be the civilization that arises. I mean, if maybe there's a 1 in 10,000 chance if you industrialize, you survive long enough to colonize the galaxy, and there hasn't been enough time for someone to have made it. So could just be a numbers game.
Yeah, sweet. Thanks.
Sure.
What do you think of Anders Sandberg's ice-tivation hypothesis, that maybe the aliens are just waiting for background temperatures to cool so that they have more negentropy in order to be able to run their machines?
Yeah, I mean, I think that makes a lot of sense for most of what you're going to do, right? The argument there is that as the universe cools, you get sort of more bang per unit of free energy. So you kind of want to wait. But I still think if you're going to have that strategy, you're going to be afraid of the Genghis Khan-like civilizations. So you'd want to send out probes, grab as much energy as it can. You'd grab all the planets and something, you'd send it into your central black hole, and wherever you're hanging out, then you'd wait. But we don't see that, right? So even if you do want to wait, and you do want to mostly sleep, you're still going to want to use this time to send back, free energy and to protect your region. Unless, of course, you realize that, hey, it turns out we're pretty much alone, so we don't have to worry about anyone else. And then, of course, stars are wasting energy, right? So you'd want to turn off stars. I mean, I understand they're not wasting a huge amount of energy compared to how much is out there, but still they are wasting a little bit. And, why, if you're so concerned about free energy, why not just capture all the free energy you can? Why not optimize on that dimension?
Michael Zhang is asking, what do you think of the theory that intelligent life is rare and we're the only civilization that has ever arisen in the galaxy or the universe?
That's certainly a possibility. That does make us really, really important, though. And not just important compared to all other life, but important compared to other sentient humans that will exist. Because, if you as I said before, people who existed before 1970, they couldn't destroy us. People who existed far enough in the future will have started to spread out, and we will be beyond any ability to destroy us. So that makes us like really like 1 in a trillion squared level of importance. I mean, most of us have probably talked to someone who's talked to someone who's talked to the President of the United States, who could destroy the world and end all of this. How the heck did we get that important? So that we should be confused that we're that important of all the sentient beings that will ever exist. You know.
This is Joshua. As long as we're talking about strange hypotheses, what do you think about the idea that the civilizations drop out of our space-time energy continuum, as in Greg Egan's science fiction, just go traveling into other, whatever you call it, dimensions, before they make a lot of electromagnetic noise?
Okay, that's certainly a possibility. I mean, you can imagine them going to other universes, but it shouldn't be that costly just to rearrange this current universe the way you want. I mean, let's imagine we're going to do that. We, you know, 1,000 years from now, we figure out how to go to multiverses, other universes that are better than ours. But, you know, if we were going to do that, wouldn't we maybe launch a few von Neumann probes to go around and help the civilizations that we've left, or teach them our ideology, or, you know, do whatever in terms of our philosophy, right? It's not an either or.
Mm-hmm.
So, you know, when the Spanish found the New World, they weren't like, well, gee, this is better than Europe, let's just abandon Europe. They're like, no, we want both.
Yeah.
Why wouldn't you do that? I mean, maybe, but it seems unlikely that you can only move to the multiverse if you completely leave our current universe. I don't see how that could work. I mean, maybe, again, something weird is going on, and maybe that is the weird thing.
Mm-hmm. Anyone else have any questions? So, you know, just as in a face-to-face talk, there's usually a lecture and then Q&A, and then people break up into small groups and have a discussion. So we found it works very well. We do it this way in video chat rooms. I see there are 22 people so far, but once you come to these rooms, feel free to move around. As the day goes on or the night goes on and people leave, you'll probably want to consolidate into, you know, fewer rooms, and that's fine. Right now we have 3 rooms.